Being afraid of heights, but not wanting to look like a scaredy cat on vacation, you let your friends convince you to jump off of a cliff into the water below. You close your eyes and run straight off the edge with a speed of 8 meters per second and land in the water 18 meters away. How fast are you moving in the X and Y directions when you hit the water below? Our cliff is drawn. There's you running with a speed of 8 meters per second off the cliff, so that's going to be a horizontal velocity. In green, all of our up and down Y numbers exist, so that would be displacement in the Y, which we don't know, and our acceleration is down negative 9.8 meters per second squared. In the X direction, we do know that we're going to land 18 meters away, so we have that on the picture as well. Plugging our numbers into our X and Y columns, I knew the displacement was 18 meters, and I know that my velocity was 8 meters per second. Going up and down, I don't know the D, but I do know my initial velocity is 0 because I ran straight off the edge. There was no jumping up, there was no jumping down, which you can't really do. So you just ran straight ahead. The acceleration is negative 9.8 meters per second squared. So what are we trying to solve for? The question says, how fast are we going when we get to the water below in both the X and in the Y directions? Well, X is really easy, because our X velocity never changes. It's constant velocity in the X direction. So it doesn't matter if we landed here or way over here. It doesn't matter how far the cliff is, how far we're going to fall. If we run off the edge with a velocity of 8 meters per second, then our final velocity in the X direction is still 8 meters per second, because we don't get any faster going to the right or left when we're a projectile. In the Y direction, we are looking for final velocity. We don't have enough information yet to solve for final velocity here because we only have V naught and A, but if we had time, which we can solve for in the X direction, we would be able to get the last piece that we're looking for in this problem. So solving for time in the X direction is pretty easy because it's a constant velocity thing going left and right. So we're going to use D equals V times T, divide by the velocity, D over V equals time. So that would be 18 meters over 8 meters per second for time. When I plug that in to my calculator, I get 2.25 seconds for time. I can now use that in the Y direction to solve for the final velocity, which is the thing that I want. I'm going to pick the equation that does not have D in it because D is the thing I don't have and don't care about. So that would be VF equals V naught plus AT. We don't have to do any algebra because the equation is already set up for VF, which makes this one very, very easy to finish. VF equals, V naught is just 0, so I'm not going to write it, negative 9.8 meters per second squared multiplied by time, which is 2.25 seconds. And that's going to give me a negative 22.05 meters per second. It's negative because you are falling down.